The sun rises every morning like it always has. Warm, predictable, life-giving. Now imagine looking up at the sky and seeing something else instead. A perfect circle of darkness, bending the light of distant stars around it. No sunrise, no warmth, just a silent gravitational abyss hanging where the sun once was. In one corner of the universe stands the engine of life in our solar system, a star so powerful it controls the motion of every planet. In the other corner lurks the most extreme object physics allows, something so dense that even light cannot escape it. This is not fantasy, this is a real cosmic comparison. Black hole versus the sun.
Before we dive deeper into this cosmic battle, hit the like button and subscribe if you're fascinated by the most extreme mysteries of the universe. On Space Facts, we explore the universe beyond imagination, and today's showdown might completely change how you see the sky above you. Let's start with the basics. Who are we comparing? The Sun is a G-type main sequence star about 4.6 billion years old, sitting at the center of our solar system. It contains 99.8% of all the mass in our planetary neighborhood. Every second, deep in its core, hydrogen atoms fuse into helium under immense pressure and temperature. That fusion releases energy, an almost unimaginable 3.8 times 10 to the 26th watts every second. That energy travels 150 million kilometers to Earth, powering weather systems, oceans, plants, and ultimately life itself. Now, what is a black hole? A black hole is formed when a massive star reaches the end of its life and collapses under its own gravity. When did this process first happen? Likely within the first billion years of the universe, when giant stars lived fast and died violently. Where do we find black holes today? Everywhere, scattered across galaxies, and especially at their centers. Our own Milky Way galaxy hosts a supermassive black hole called Sagittarius A star, quietly shaping the motion of stars around it.
How does a black hole work? At its center lies a singularity, a point where matter is crushed to infinity density, at least according to current physics. Surrounding it is the event horizon, the boundary beyond which nothing can return. Cross that invisible line and escape becomes impossible, not because it sucks like a vacuum cleaner, but because space-time itself curves inward so steeply that all paths lead deeper inside. Here's where things get interesting. If you replace the sun with a black hole of exactly the same mass, Earth would not suddenly spiral into doom. Why? Because gravity depends on mass and distance, not on whether the object is a glowing star or a black hole. If the mass stays the same, Earth's orbit would remain stable. We would continue circling at the same speed and distance. But there would be one catastrophic difference: darkness, instant and absolute. Without the sun's radiation, temperatures on Earth would plummet within days. Photosynthesis would stop. Within weeks, surface temperatures would drop below freezing globally. Within a year, the average temperature could reach -70 degrees Celsius or lower. Oceans would begin freezing from the top down. Life as we know it would collapse. The black hole wouldn't destroy Earth through force, it would erase life through absence. Now let's compare raw power. The sun shines steadily through nuclear fusion, generating energy from within. A black hole is invisible on its own, but when it feeds, infalling gas and stars form a superheated accretion disk that can outshine entire galaxies. Some even launch jets stretching thousands of light years. So, who produces more energy? A feeding black hole can release far more than the sun, but it's violent and temporary. The sun's power is steady and life-sustaining. One builds, the other consumes. In size, the sun spans about 1.4 million kilometers, yet if compressed into a black hole, all its mass would fit inside a sphere just 3 kilometers wide. That's the contrast between fusion pushing outward and gravity crushing inward. If a stellar black hole met the sun, gravity would win. The sun would stretch, tear apart, and spiral into a blazing disk before crossing the event horizon, a gravitational dismantling, not a typical explosion. And this isn't a theory. In distant galaxies, astronomers observe stars being ripped apart by supermassive black holes, captured as sudden flares of light, real cosmic tragedies unfolding millions of light years away. When will our own sun face such a fate? Almost certainly never. Sagittarius A star is about 26,000 light-years away from us. The Sun orbits safely within the galaxy. But billions of years from now, the Sun will face its own dramatic end. It will expand into a red giant, possibly engulfing Mercury and Venus, maybe even Earth. Eventually, it will shed its outer layers and leave behind a white dwarf, a dense stellar core slowly cooling over trillions of years. So, who wins in black hole versus the Sun? By gravity, the black hole dominates. By life-giving power, the Sun stands undefeated. In endurance, small black holes might outlast stars, slowly fading through Hawking radiation over unimaginable timescales. But this isn't about winning, it's about balance. The Sun brings stability and life. Black holes drive transformation, shaping galaxies and cosmic structure. Without stars, no heavy elements. Without black holes, galaxies lose form. Creation and destruction work together in cosmic evolution. When you feel sunlight on your skin, remember how rare that steady warmth is. In a cold universe ruled by invisible gravity giants, our Sun's quiet reliability is what makes life possible. The universe is not a simple battleground of good versus evil. It is a system of forces playing different roles across unimaginable scales. Black holes bend space-time to extremes. The Sun bends the destiny of life around it. One sculpts galaxies, the other sustains civilizations. And in that comparison, perhaps the real winner is perspective, because understanding both reminds us how small we are and how lucky we are to orbit a star instead of a shadow. If you want more deep dives into cosmic mysteries, make sure you subscribe to Space Facts and turn on notifications. The universe is vast, powerful, and full of surprises, and we're just getting started.